Today we are going to see how to derive an expression for electric field which is due to a dipole along the axial point, which is from chapter Electric Charges and Fields, Physics, class 12. Okay. So to derive this expression, first we have to understand what is electric field, dipole and a axial point. Let's see what is electric field. Electric field is a region or a space surrounding a charges which other charged particle experience a force. So example, if I consider a charge Q, okay, force charge, and I'll consider one more charge which is Q, okay, and there will be a force experienced by these charge. It can be defined as the test positive charge is placed at a point in an electric field. Okay, so electric field is force per the charge. So electric field is represented by E, and electric field can be defined as the force exerted on a unit positive test charge. This is the test charge, the force exerted on the unit positive test charge placed at that point in the field. Electric field is equal to force per unit charge. Unit of this is Newton per Coulomb, we can see. Direction of the electric field is same as the direction along the unit positive charge. Example, if we say I am placing a positive charge here. Okay, so how is the direction of electric field at point P? At point P, I'll place positive unit positive charge. Okay, so the like charges repel. So the direction of field line is upward, that is away from the charge. Okay, and if I consider point R here, I'll place a unit positive charge. The direction is away. Okay, or I'll place here somewhere Q. Okay, here also the same, the like charges repel. Or I'll take a negative charge. Okay, negative charge minus Q or negative charge. I'll place at point P. How is the electric field direction? So I'll place a unit positive charge here. Unlike charges attract, so it is towards the charge. R, positive charge I'll place, it's towards the R. Okay, here Q, if I place positive charge, it is also towards the negative charge. Okay, so and the electric field, we know that electric field is equal to force per Q charge. Okay, and we know Coulomb's law. Coulomb's law is also one of the important law which we learn in electric charges and fields. Coulomb's law states that the electrostatic force of attraction or repulsion between 2 point charges Q1 and Q2 is directly proportional to the product of the charge and inversely proportional to square of distance between them. And because we remove the proportionality symbol, we'll introduce a constant, which constant is 1 by 4 pi epsilon naught. Okay, force is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square from Coulomb's law. Okay, this is from Coulomb's law. Have to substitute the value of F in this equation. But if we consider here, what is Q1 and Q2? Q1 is a source charge and Q2 is a test charge. Okay, so on substituting, force is equal to 1 by 4 pi epsilon naught Q small q into capital Q divided by R square. Okay, on substituting this in equation 1, we get electric field is equal to 1 by 4 pi epsilon naught Q into Q by R square into Q. Okay, this Q gets cancelled. So electric field is equal to 1 by 4 pi epsilon naught Q by R square R cap in vector form, where R cap is a unit vector. Okay, we have learned about electric field. Okay, electric field formula is this one. Any one we can use, either this or this. We'll see about the dipole. Dipole is a pair of equal and opposite charges. A pair of equal and opposite charges. Point charges, that is plus Q and minus Q, which are separated by a distance of 2a. Okay, small distance 2a. This is the dipole. And the line which joins dipole, both the charges, are axial line. At the center is the origin, and the line which passes through the axial line and at the center is known as equatorial line. Okay, and a pair of equal and opposite charges separated by a small distance 2a, and the line which is passing through the which are just joining plus q and minus q are axial line, and a line which is passing through axial line and at the center is known as the equatorial line. Okay, and next we have also a dipole moment. Dipole moment is along the axis of this dipole. Okay, or else we can say it is from negative charge to the positive charge. Dipole moment is just the product of magnitude of either one of the charge and the distance between the charges. Okay, this is the dipole moment. Now we are clear with what is electric field and a dipole moment. The derivation, first we'll consider two charges, positive q and negative q. Positive charge and negative charge, q just represent the charges, and the distance between positive charge and the negative charge is 2a, we know. So from origin to positive charge it is a, and from origin to negative charge it is also a. And next is we'll consider a point which is an axial point, right? Axial point is which is horizontal, okay, and axial point is just beside plus q. At some point we'll take p. Okay, axial point is at some point p. Next, electric field. Okay, electric field of positive q and electric field of negative q at point p we have to check. First, we'll place a unit positive charge at this point. Okay, unit positive charge at point p. If we place the positive q charge electric field, okay, it will be away from p, cause like charges ripple. Okay, electric field due to positive q. Next, again we will place unit positive charge at point p, but now we'll check electric field for negative charge. Okay, so the electric field is just towards negative q, that is the unlike charges attract. Okay, now we know electric field of positive q and negative q, and we are considering a point p which is of distance r from the origin or center of the dipole on the side of the charge q, positive q. Okay, and if we see this is a, okay, so from point p to negative charge, how much is the distance? R plus a, right? So r plus a. Next is from positive p, point p to positive charge, how much is the distance? This is total is r, and only from point q, positive q to origin is a. So point p to positive q is a. Okay, now we got to know the distance between p of p and minus q and p and plus q and p and o. Okay, so whatever we have considered that we will write. Okay, so first we have considered the point p, right? Point p, okay, which is of a distance, let that be a distance of r from the center of the dipole. Okay, from the center of the dipole, okay, on the side of the charge plus q, side of the charge plus q. Next is electric field due to positive charge. Electric field due to positive charge. So first, before writing this, we have to remember the formula which we have just derived in this one. That is, electric field is equal to 1 by 4 pi epsilon naught q by r square r cap in vector form. Okay, we'll just take vector form here also. And 1 by 4 pi epsilon naught. The charge here is positive charge, and the distance between that point to positive charge is r minus a the whole square and p cap. Okay, p cap is a unit vector along the dipole. And here also we can write the dipole moment. Dipole moment is from negative to positive. Okay, this is the dipole moment representation. Next is electric field due to negative charge. 1 by 4 pi epsilon naught. Here charge is negative q. R plus a the whole square. The distance between point P and negative q is r plus a. So r plus a the whole square p cap. Okay, we'll just write p cap is the unit vector which is along the dipole axis. Unit vector along the dipole axis. Or we can just say it is from negative q to positive q. And for this, we have to know next, after all this, we have to know the total field at this point P. Okay, total field at point P. The total field at point P is just the sum of electric field due to positive charge and electric field due to negative charge. Okay, we'll substitute. So electric field due to positive charge is 1 by 4 pi epsilon naught q by r minus a the whole square plus 1 by 4 pi epsilon naught minus q by r plus a the whole square, and p cap is the unit vector. Okay, and the next one is the common terms we have to see. 1 by 4 pi epsilon naught is common and q is also common. We'll take out q by 4 pi epsilon naught outside. Okay. E is equal to q by 4 pi epsilon naught. Remaining will be 1 by r minus a the whole square by r plus a the whole square. Okay. And E is equal to q by 4 pi epsilon naught. We'll take LCM. Okay. R plus a the whole square minus of r minus a the whole square divided by r minus a square r plus a the whole square. Okay, and next we'll solve. Okay, q by 4 pi epsilon naught will not work out on the one which is outside the brackets. Okay, and now is a plus b the whole square, a square plus b square plus 2ab minus of a minus b the whole square, a square plus b square minus 2ab divided by, we'll write this term separately. If it is a square, a into a we can write. So, r minus a the whole square, r minus a into r minus a. Next, r plus a into r plus a. Okay. Next step is E is equal to q by 4 pi epsilon naught. R square plus a square plus 2ra will open up the bracket. Okay. Minus r square plus into minus minus r square plus minus into minus is plus 2ra divided by, see, r minus a r plus a, r minus a r plus a minus b into a plus b is equal to a square minus b square. So 2 times we'll write that. Okay, I hope this step is very much clear. I have written it clearly. A minus b into a plus b is a square minus b square. R minus a into r plus a is r square minus a square. For both the same. Okay, and next step. Here some terms are getting cancelled. Okay, r square, a square are getting cancelled, and E is equal to q by 4 pi epsilon naught into 4ra. 2ra plus 2ra is 4ra divided by r square minus r square the whole square. Okay, it will be very much lesser. Okay, in some situations. Okay, it may be 0.1, but 0.1 square will be, it will be very much lesser. Okay, so we are just neglecting a square in this. Okay, so for r is much greater than a, so therefore a square, r square minus a square the whole square is equal to r square into r square, which is r power 4. Okay, so E is equal to q by 4 pi epsilon naught 4r by a, and we have solved it, so we can just write it directly r power 4 pk. Okay, next r power 4 and 1r will get cancelled. The remaining will be r power cube. Q by 4 pi epsilon naught into 4a by r cube. Right, now we know that is dipole moment. I have already told it. Dipole moment is equal to magnitude of either one of the charge and the distance between them. Product of magnitude of any one of the charge and distance between the two charges. Right. So E is equal to 2 will take out q into 2a divided by 4 pi epsilon naught r cube p cap. Okay. So q into 2a is p. That is dipole moment. Right. So 2 into p, dipole moment divided by 4 pi epsilon naught r cube. And in vector form, if we have to write, E is equal to 1 by 4 pi epsilon naught. So 1 by 4 pi epsilon naught is a constant k. Okay, we'll just write it separately, and we don't want to cancel 2 and all. Okay, into 2p by r cube. This is the final equation of electric field due to a dipole along the axial point. Hope this will be more clear and helpful to you. Thank you for watching it, and also read my teaching. Thank you.